Welcome back. This is Tony Verbsky here. They call me Verb. Hopefully everything's going okay with your progress. This is going to be a lecture over section 9.4, 9-4, 9.4 in your trig book. Once again, listen to the lecture, take notes if you want, read the section, excellent reading, excellent problems, and then finally do your MML, my math lab. It's pretty much how this class works. You got to understand, MML has a ton of resources in it also, has animations and all sorts of tutorials. So between the three of us, or three things, you should be able to figure it out. Anyway, today we're doing right triangle trig, meaning I give you a right triangle, and if they go side A, this is angle A, and if they go side B, this is angle B. 90 degrees is usually sine the angle C, and this is the hypotenuse. And today we're doing a little TOA work, hyphen, slash, 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 hyphenated. And, I'm a Cho-Shikao guy, which is basically the reciprocal version of that. Trust me, the Sha things helped me a lot in calculus, and so has Cho. So maybe we don't use a lot here, but I think like 7 years ago I started saying Sha, and it's actually helped me in my calculus class on some of those related rate problems that you'll learn. If you run into it, you might be saying Sha. That's all I can say. Anyway, moving on. So what's going to happen is we want to figure out all six things. Three angles, which obviously in right triangle trig we know, so technically we'll want to be able to figure out the five things. Now the easiest problem is the stupid problems, because if I give you this 5 and I give you this 9, you know the Pythagorean theorem's in play. Now if they don't officially label everything, it's up to you to officially label everything. If you call this A, this is big A, forcing this to be big B and little b. Now, if you got two sides, it's just a squared plus b squared equals c squared. And then 5 squared plus b squared equals c squared. B squared, 81 minus 25. I'm going to actually get my calculator out today. Don't want any of those unnecessary mistakes. 81 minus 25, still early, 56. Oh, what a terrible number. I'd rather have like a 17, something that's prime. B equals plus or minus the square root of 56. Now, we all know that's 8 times 7. But the 8, well, that's a funny looking 7. Here we go, 7. 7's prime. Let's get rid of the negative because there's no such thing as a negative distance. So 8 is 4 times 2. So that's 2, square root of 4, 2 times 7, radical 14. And that's side B. Now that we know B, my theory is if you want to find the angle, we're going to have to use some inverse trig. Inverse trig isn't formally developed yet, but as long as you're in the first quadrant, nothing bad happens. Trust me, when you're not in the first quadrant, you can run into a world of hurt. We will go over that sometime later when we talk about inverses, but trust me, it's actually way more complicated than it seems. But today you won't be hurt by this. What I do is I just pick the nicer of the numbers. I don't want to use 2 radical 14. I'm sitting here on angle A, and I'm wondering what angle A is, and I see a nice number opposite, and I see a nice number hypotenuse, so I say so. So sine of A is 5/9, and A, so what you do, and this isn't pretty, but I inverse sine, and I inverse sine. Now, inverse sine of sine releases the A, and my angle is inverse sine of 5/9. Now, I'm a 100% all-in radian guy, I love radians, but anytime I do inverse, I always cheat degrees first, so I'm not even going to hide that from you. So on my calculator, which I didn't bring up today, let's see if it's still live, see if it's still working. Yay. Mode. Okay, see I'm in radians. That's a good thing. But when I'm using inverse, I'm going to cheat. So inverse sine of 5 divided by 9, and I pick up A to be 33.748 degrees. Just a second, let me pause. Got a telephone call. Hey, I'm back. I just found angle A to be 33.748 degrees, and therefore angle B is on, get this calculator back on, 90 minus the last answer is 56.251. In lecture, I'll be a truncator, but no, in MML, you're actually a rounder. You need to look at the fourth digit. Anyway, I'm looking good. I think I have all the sides, A, B, C. Yep, we're all good. So, moving on. What happens if I give you an angle like 31 degrees and I give you a side like 5? Is that enough to finish off the triangle? Well, if I'm a go to label, I'm going to call this big A, looking for little a. The 5 is going to be B, big B, of course C, and little c. And I'm looking, and I need an opposite, I have an adjacent. So I'm looking for formulas that have an adjacent in it, because that's how I drew my picture. So it's not so, but it's ka, and it's to-a. So both are going to work to move this problem along. So since I chose to look at an opposite and adjacent, let's go tangent of 31 degrees equals A over 5. Then all we do is multiply both sides by 5, and the 5's go away, and then we type on our calculator 5 times tangent 31, and we get A to be 3.004. Now, I'm not much of here's what I do basically. I take my answer and I go stow alpha A, even though it's a big A. I don't care. Now, there's two ways to get your third side. Now, I don't traditionally do it this way. You know, A squared plus B squared equals C squared. And, you know, on my calculator, alpha A squared plus 5 squared equals C squared, square root, last answer, and I get C to be 5.833. That's not the way I would do it. I guess I would be inclined to go sine of 31 equals A over C. Cancel that. Cosine, as stated above, is adjacent over hypotenuse, so 5 over C. And therefore, now, let's talk about this. Technically, you're cross multiplying. So it's really C times cosine 31 degrees equals 5. Then you're looking for C, and you divide by cosine 31. So C equals 5 cosine 31. But traditionally, when you're here, you go cosine 31 equals 5 over C. You put the C up there, the cosine 31 down there, and you get C equals 5 over cosine 31. And then we get 5 divided by cosine 31, and you see that it's exactly what I had before, 5.833. Now the only thing left is the obvious, 59 degrees. That's what B is. Moving on, we got some terminology to go through. So in math class, we turn and burn counterclockwise, picking up 31 degrees. In science class, you turn off the north, and it's called a bearing angle. And there's different ways to talk about this. Sometimes they're very specific, like, but here, let's find it. So 59 degrees. Sometimes they just say theta bearing, the bearing angle is 59 degrees, and basically turn clockwise off to north. Sometimes they say it's 59 degrees west of north. So you know to go, well, east of north. That's south. Here we go. Here's the mountains, west, east. So it's 59 degrees east of north. Either way, that one's really obvious, but I just assume they just give me the bearing angle is 59, so I just turn and burn 59. Then I change it back to the math angle 31, so I feel like everything I'm doing in this class works. So if they give me a bearing angle, I switch it back to a math angle, do the problem, switch it back to a bearing answer. Your physics teacher, they'll just stay right in that bearing realm. They'll draw triangles and they'll solve the triangles, and they'll never ever use the 31 degrees unless it's in their construction. So anyway, if theta, I call it bear, like B-A-R, like roar, is 117 degrees, you know, what angle am I talking about? Well, that means you're turning and burning 117 off the north. You know that's 27 degrees negative in math realm. So you can go with a negative 27, or you can turn around and call it 333 degrees. Both work. So you got to be able to go back and forth. If theta bear is 30 degrees west of north, well, you're here, and this is east, and this is west, and you're off the north. They're saying turn 30 degrees to the west. Now, we know we're really at 120 degrees in math realm. So theta bear, 30 degrees west of north, 120 degrees in math land, and then, you know, they actually ask you some of those questions to convert them. So it's pretty good stuff. You should really do the reading. The book does a phenomenal job on this. Okay, that said, and once again, there's a really good problem involving bearing in the book. It's example 5. I don't want to steal their thunder. They do an excellent job. I just assume work a problem out of the back in the problem section. So I'm not going to do that right now. Now, when you work in these applied problems are difficult because, you know, you've never worked them before, and some of them seem tricky. It's like cutting a board. You know, cutting a board by hand is kind of tricky. Cutting it with a hand saw, skill saw, electric saw is tricky. Cutting it with a chop saw on a table is kind of tricky. There's a learning curve to working applied problems, and basically that's why we practice. Now, there's kind of these traditional rite of passage problems, so I'm going to address this one. So basically, you're looking here. Here we go. So you're here 100 feet away, right here. And you're looking up at the top of this, say, building. Here, let's draw a building, door, windows. And there's a certain height there, of course. Now, we can see that we're looking up at like a 61-degree angle. And if we step back some mystery distance, d, this distance here is 100 plus d, and this angle is 30 degrees, what is d and h? So this is a traditional kind of trick problem. Now you can see hypotenuse is not in play. It's totally a TOA, an opposite over adjacent type of problem. So tangent of 61 equals h over 100. Tangent of 30 equals h over 100 plus d. You get two equations. Now, this is the trick part. This is why you take the class. This is why you listen to the lecture. This is why you read the book. Just, sorry about this, got on the calculator. Isolate h. So h is 100, just move that up, times tangent 61. Move it up. H is 100 plus d, tangent 30 degrees. Since h equals h, 100 tangent 61 equals 100 plus d, tangent 30. Now, obviously, we're going to try to solve for the letter d. Now, you could turn this to decimal if you really wanted to. Pretend the number's 7. And when you distribute over here, this number here is like 5. So you go 7 minus 5. You're going to try to isolate the d. But I'm not going to do that. I'm going to just keep all the symbols there. So this is just a number, move it over. So 100 tangent 61 minus 100 tangent 30 equals d tangent 30. Now, whatever this number is, we're going to divide by tangent 30. And we got d to be, all right, here we go, parenthesis left, 100 tan 61, parenthesis, minus 100 tan 30 degrees, parenthesis, oops, back her up, parenthesis for the numerator, divided by tangent 30, close it off, enter, 212.470. And I didn't put units, but that would be like feet. Let's say it was 100 feet originally. But, oh, by the way, STO, alpha, D. So I got all the decimals, the 6 or 8 on my screen and 30 more internally. Life's great. We have a lot of decimals here. Now, you know, H is one or two things. I like this one better. That's kind of weird. Let's see if it actually checks out. We actually knew what H was from the beginning. I've worked a modified version of this problem. So we know H from the get-go. It's kind of dumb. H from the get-go was 100 tan 61, 100 tangent 61 degrees. The problem I was working, I modified so it was different than your textbook, but I kind of created a stupid version there of it. So please, when you work in this problem, work it in the same spirit that I just worked it, because The problem that's the traditional tricky one is really the one that's in the book. So anyway, on 100 tangent 61. So the height you could have found right away, and you could have really made this problem simple. You understand, I lecture on kind of on the fly here, and to create that problem, like, you know, I just changed the number in the book, moved the variable, you know, created this kind of dumb problem, but trust me, the method I use is the one you're going to want to use, and the one you're going to want to remember. So if you get two variables, you're going to need two equations, and basically you traditionally isolate one, and then you solve the other, and then you back substitute to find the other one that you isolated. Okay, I'm not very proud of that one, but it'll work. You know, I'll redo this lecture next time, you know, next year. Anyway, hey, by the way, I think you guys understand this is the first edition of the book. So all our lectures that we have saved, you know, are basically out the door, and we have to recreate all our lectures. So this is not an exact science. We just found out we actually had a new book, and we had to like redo all our My Math labs and all our, we had to pick all our problems again about 3 weeks ago. And basically they didn't even have all the right stuff to us till like a week ago. So we're rallying here. So you're gonna have to cut me a little slack. In the book, this is problem 14, page 661. They give me B to be 15 feet, and they give me C to be 17 feet. And you got to understand that C goes with big C, which is 90 degrees. And you got to understand that A squared plus B squared equals C squared. So you need to know that they're using A, B's, and C's. The A and B are the two sides. The C goes with the hypotenuse, and it's a 90-degree angle. Anyway, you get A squared plus 15 squared equals 17 squared. A squared equals 289 minus 225. And on, sorry, using my other calculator, 289 minus 225, 64. A equals 8, technically plus or minus 8. So I don't know if you realize this, but in real life, there is an 8, 15, 17 special right triangle. Everybody knows the 3, 4, 5, and you double, 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 the 6, 8, 10, but hey, there's an 8, 15, 17 out there. So you need to find the 8, which was A, you did that, and you're looking for angle A, and then this guy is B, so you're looking for angle B, and you actually know what C is, it's 90. So if you're looking for an angle, you just say, hey, I'm looking for an angle, and that's 8/17. And then, once again, I'm not trying to make this look pretty. It would be nice that if our stuff was always pretty, I guess. But in math, you inverse sine both sides, and you get inverse sine 8/17, angle A, inverse sine 8 divided by 17. 28.072. 28.072 degrees. So alpha A, 90 minus alpha A. B, 61.927. Once again, I'm a truncator. MML to rounder, so that 7 would be an 8 in MML. So got to be careful. When you're working MML, once again, understand they're still in their first version. There's going to be mistakes left and right. I'll put this out in an announcement, but I do inflate your MML homework grade 3% just because of mistake. And I work most of your assignments, so I am aware that in the first assignment there was a pretty major mistake on a problem. Like everybody was like 171 degrees, and the MML had four choices of 155 or something dumb like that. So you're going to get 3%. My advice is you keep working a similar problem and you click on it and guess. Similar problem, click on it and guess until you actually get it right. Then you can actually score 103%. Probably shouldn't be telling you this, but that's the name of the game. They put you through the struggle. You know, you should be rewarded in some way, because we're all sitting there confused, wondering what the heck's up. So, you know, there you go. There's a little suggestion for you. You can inflate your homework category just a little bit. Right? That'd be good. All right. So here's a problem 45. Keep in mind, I see the problems, I'm looking at them, I feel like I want to work this. So it has nothing to do with me being a good teacher. I just see two ships and I want to work the ship problem. It says a ship leaves port and sails on a bearing of 28 degrees 10 minutes. Here we go. So theta bear equals 28 degrees 10 minutes, and then they go east. I'm like, thank you for over exaggerating. I really officially know where I am now. They didn't really need the east, because you could have just said theta bear was that and you turn this to that area. So I like it when they do that. Now here we go. Now it's early, we need to practice on our calculator anyway, so you can go 90 minus 28 second angle degrees 10 second angle minutes and get 61.833 forever. Now you could change that to minutes right away. Second angle convert to degrees, minutes, seconds, and you get 61 degrees 50 minutes. That's the angle we're working there, and that's a ship leaves the port, so let's call that ship A. Then we got another ship leaves the port on a bearing of, okay, so theta bear 2. So for ship B is 61 degrees 50 minutes, and they put a little south in front of that, and they go east. So now they force you to start off here, and you got to go east. So you're turning 61 degrees, let's change that to degrees, 50 minutes, and you're like, wait a minute, something's weird here. And you're starting to figure out that this angle is 28 degrees 10 minutes, and then you go, this is 90, and then, you know, start putting everything together here. Now, it does help to actually read the problem. I have the, I don't know, it's not a gift. I'm basically a poor reader, so sometimes I just like, oh, let me see if I know what's going on. Most of the time it works out, but, you know, I shouldn't read the book. If the first ship sails at 24 miles per hour, so ship A is 24 miles per hour, and ship B sails at 28 miles per hour, and they want to know the distance D when T equals 4 hours. So right away, I'm going right back to middle school. Distance equals rate times time. So distance for ship A equals 24 times 4, 96. Distance for ship B is 28 times 4 is 108. And these are miles, and these are miles. Well, I don't even get to use trig, because you know you're looking for hypotenuse. So it's side squared plus side squared equals c squared, and in this case, distance squared, and d is the square root of 96 squared plus 108 squared. So 98 squared plus 108 squared, enter second square root, last answer. And I get D to be 145.835 miles. And then I solve the problem. You got to understand, some of these problems are going to be kind of hokey, meaning they give you a special case to get you into a right triangle kind of situation. Don't worry, later on they won't give you that. They'll give you kind of a non-right triangle problem. So when you're working these, you're like, surprise, I got another 90-degree angle. That's because you're in a 90-degree angle section. So I was all pumped up about that. I'm going to do another one just for kicks. This is a really common problem. So you got this 6 foot tall person, woman, excuse me, I'm like the world's greatest artist here. She's 6 foot tall, and there's a light post, and this has a certain height, and there's a certain angle through the top of her head to the top of the post, and we happen to know it's 24 degrees. I'm thinking about problem 31, but I just altered the numbers. And she's casting a shadow S. Now what we do know, that she's 6 foot tall, find the length of the shadow cast by the woman, and this is all they give us. So she's some distance X away, and I'm sitting here looking at the problem, and once again, I don't see any hypotenuse action. So what I see is some opposite over adjacent stuff. So tangent of 24 degrees equals 6 over x, but tangent 24 degrees equals h over x plus s. Okay, had to take a little break there. The problem in the book, it's not a post, it's actually the sun. I believe if you run into this, you're going to need to know the distance of the sun from the earth. On this problem, I have 2 equations and 3 variables. So I know the problem I made up, if you have 2 equations and 3 variables, I should have gave you 1 more. So it is known that the height of the post is 30 feet. So if tangent of 24 is 6 over x, I solve for x, and that's 6 over tan 24. So you plug that in there, and we're creating kind of a mess here. It doesn't bother me, but this h, I had to give you that h. So when you're working your MML, pay attention. If it's a sun problem, somewhere we need to figure out what the distance of the sun is from the earth. They kind of expect that you know that, so if you get the problem wrong, make sure you read through why you got it wrong, and then they'll tell you the distance of the sun from the earth, and then you'll be good. Else, maybe you got this problem here. 6 over tan 24 plus the length of the shadow. Now, the question is, do you want to brute force this, or do you want to work it with decimals? I'm going to brute force it. So here's what I'm going to do. So tangent 24 degrees is 30 over this stuff. But I got to find a common denominator. Now, whenever I add fractions and it looks like this, I use the crisscross applesauce method that nobody ever taught you. So 6 times 1 plus s times tangent 24 all over this times this, which is just tangent 24 degrees. Now, I keep this the same, and I turn to 30 over 1, and I copy dot flop. So I get 30 over 1 times tangent 24 over 6 plus s tangent 24. Now, I can see a tangent 24 on both sides. So what I'm going to do is divide both sides by tan 24. And sorry about the mess, but this will clean things up big time. 1 equals 30 over 6 plus s tangent 24. Now I'm a cross multiplier guy, so I get 6 plus s tangent 24 degrees equals 30. Bring it on over, tangent 24 degrees equals 24. I forgot my s. Now divide by tangent 24. Divide by tangent 24. S equals 24 divided by tangent 24, and I get 53.904 truncated feet. That's the length of the shadow. I think we'll try one last problem. So there's this problem 35, and I'll work it exact this time from the section, page 662. So they even have it all drawn out, but they got this camera, and they use the word angle of depression. Find the angle of depression. This is the angle of depression. And there's some teller, I mean a head teller, must be a bank teller, and we know the camera is at 5.93 feet, and we know the teller is at 12.02 feet. They must have some type of laser tape measure that's very accurate, and they want to know this angle here. But this angle here is this angle here. Alternate interior angles are the same when you got parallel lines. So we just got to find this angle. But I'm sitting on this angle, and I see the opposite. I see the adjacent. So I'm going tangent of A is 5.93 divided by 12.02, and A is inverse tangent of that stuff. Once again, we don't truly understand inverses, but as long as it's less than 90, we won't have any issues. Second tangent, 5.93 divided by 12.02, and I get 26.259 degrees. Once again, if you're MML, read your direction, be a rounder. By the way, in this problem, rounding and truncating is the same. Well, I know I'm going to work your MML problems because this section can be rough. So don't be surprised if I struggle a little bit here and there. I'm looking at all the problems in the textbook, and they all intrigue me, and I know I can figure them all out. But just remember, I don't know the distance of the sun from the earth. Somebody's going to have to tell me that. And this book does this to you here and there. So don't be surprised if you get a problem wrong, and then you look at the solution, and you're going to see like, oh my, I would have never known that. Write it down, get over it, work the next problem, you'll be fine. That's it for today. I will be most likely lecturing over 9.5 sometime today, and it's a lot better section for me because it's a unit circle. Then I'll be working a lot of MML sections just like you. We pretty much have the same life, just so you know. The only difference is I have to give you a lecture, And I have to pick your problems in MML, but I already did that for all chapter 9, and I just got to work them just like you. So am I upset that MML occasionally messes up? Yeah, I get upset. I just know to get over it. So, we're here to learn trig. That's part of the learning process. And, I'm not anti-MML by any means, but it is frustrating sometimes. That's it for today. See you later. Hit my 40 minutes.